Good morning, everyone. Welcome to this session on continuous integration for web and JavaScript projects. Before we get started, I just want to ask, how many people are already doing CI for their web JavaScript projects? All right, so not a few people. So this is a basic session on the why, the what, and the different methods around building a CI system for your JavaScript code for the front end. So typically when we think about server-side projects, we think of something like something that's neat, something that's a well-known art, something that we spend a lot of time doing properly in terms of having good continuous integration around it. Unfortunately, for a lot of people, when we think of JavaScript projects, it's more like this. It's kind of just duct taped together and not very well thought out, right? And what we want to do in this session is understand what we need to do to be able to build a nice system around continuous integration for our web and JavaScript projects. Right? So I'd like to start this session off with talking about craftsmanship in general. Right? Oftentimes for web and JavaScript projects, we neglect the craftsmanship that's around it. So what does craftsmanship actually mean? Right? A lot of it is focused around caring about the quality of your code. So when we think of caring about our code, we want to have maintainability, be able to reproduce our code, and also we want to approach it from a software engineering point of view rather than just hacking something together. Right? So some of the things we do for craftsmanship and quality around our code is we take measurements for low-level code quality, and obviously in this session we'll talk about continuous integration. So we also do things like test-driven development. We have automation of tests to ensure that our code is up to the specifications that we want and other things around it, right? So what do we do in the Java world to have software craftsmanship and to have good quality around our code? We use a couple of tools, right? We use something like Clover or Find Bugs, Checkstyle, and PMD to ensure that we are approaching our code from a quality point of view, right? So we use Clover to make sure that our tests have ample coverage around our actual code. We use Find Bugs and Checkstyle to make sure that our code is of the right quality and we find things which we can improve in our code. When we think about web and JavaScript projects, right, what is it that we need to use to be able to attain these same kinds of things? So, we use Clover for code coverage, Checkstyle to make sure that we write code in the proper idiomatic style, and then we use something like Find Bugs and PMD to do static analysis of the code to ensure that it's of high quality. Right? In the web and JavaScript world, we have some similar tools that we can use. So first of all, we use something like ESLint or JSHint to ensure that our code matches a specific style that everybody on our team writes. And then we can use something like Istanbul to give us code coverage. And then, of course, there's Mocha, Jasmine, Tape, and a bunch of other tools that allow us to write unit tests. So in terms of build tools, there are a few that we can use. Right? We'll look at the ecosystem around these build tools, and then we'll do a demo with Jenkins in setting all this up. So when we think of the ecosystem itself, we have things like Node.js, NPM, and the modules which are contained within it to allow us to essentially use the tools that are already available to do these kinds of things. And of course, we have to use Node.js, which is essentially V8 or the V8 JavaScript runtime meant to run from the command line. So a lot of the tools that we're talking about in this session, like Istanbul and Mocha, etc., they're all contained in the NPM package manager. Right? So let's do a quick look at some of the tools that are available in our system. The resolution needs to be bumped up here, so bear with me just a minute. Right. Is that big enough? Okay. So when we think of a JavaScript project, even if you're using something like Maven or Ant or something like that, we typically build web and JavaScript projects with Node. And with Node, we need to have a Node-based project to do all this stuff, so we use something like a package.json. This is our descriptor file for our Node project. Right? In this, you can see that we have some dependencies. Specifically, For this project, we're going to use something called Grunt, which you probably have heard of, and then Jasmine to run some unit tests. If we go look at the actual application of the Grunt file, you can see that what we have is we've just declared JSHint as our linter or way of checking our code style. And inside our Grunt configuration, we say go and load up the JSHint task and set that as the default. And then what we can do from the command line is, let's make this a little bit bigger so you can see it. Right. So now what we can do in this specific test is we can go and run Grunt from the command line. And what this does, again, is in our package.json, we have Grunt declared as a dependency and the JSHint task and Jasmine and a few other things. But in our Grunt file, we go and declare JSHint to say, these are all the files that we wish to lint. So if we were to go into this file, and let's just do something silly like remove a semicolon and rerun our Grunt task, you'll see that the linter will fail. So this is kind of the basics around how we set up a continuous integration system, i.e. how do we run something that we can then put into a continuous integration system. So let's go fix this, and we'll run the code again, and you'll see that we're done without errors now. Right? So all these projects are contained within NPM modules, right? So when we use Grunt and Gulp or Jasmine and other tools, they all come from the NPM repository, which we specify, as I showed just a second ago, inside our package.json. All right, so we're going to just skip over the NPM part. We've looked at the Grunt file and the package.json. And one of the things I like to talk about is something called Webpack. Now, in terms of a modern JavaScript system, we use tools like Webpack or Browserify to manage our dependencies, right? And the reason we do this is to give us builds which are reproducible and use standard repositories, i.e. NPM, to go and get those kinds of things. But what Webpack is it's a module builder. It essentially takes our source code and produces assets from it. So it's suited for large projects, does code splitting, et cetera, et cetera. So when we look at what Webpack actually does, it goes and takes our JavaScript, CoffeeScript if we're using that, PNG, CSS, other files, and it produces bundles that we can then incorporate into an index.html or whatever our web application is, right? So the reason why we're interested in this is that Webpack is one of the tools that we use to produce a nice bundle that we can then ship to production or for testing or whatever it may be. So this is like the first step or one of the first steps. So in terms of CI automation, what we want to do is we want to run some unit tests. We want to do automated bundling of our assets instead of just kind of hacking it together. Again, that's why we use something like Webpack or Browserify. And once we have our automated tests that we can do for unit testing, functional testing, and integration tests, we're at the point where we can then put that into a continuous integration server like Jenkins or Travis. And what are some of the things that we want to do in our CI system, right? We do this for our Java projects already. We want automated reports. We maybe want to do automated deployment of those assets to test and staging servers. We may even want to do deployment versioning around that. So some of the things that we'll look at here is we'll do some static analysis with the linter, and we can also run advanced things like performance tests, tagging releases, and other things like that. But let's get into a quick demo. We will talk about all this stuff in a little bit of detail, but one of the things that is challenging around doing CI for web and JavaScript projects is that it does take some effort. There's not necessarily just one way to do it, so you kind of have to look around and see what other projects do for building a JavaScript or web-based system, whether you're using Angular or whether you're using React or something like that. So there are common recipes that are available, right? So you can go find a starter kit or a template project from GitHub, which will give you a lot of the things that you need to be able to build a Angular-based project or React or whatever framework that you're using. And typically these starter projects use something like Grunt or Gulp, a build runner to drive the automation around this. All right? So we've already looked at a simple build script. Let's look at something a little bit more advanced. So in this case, what we're doing, let me go to the right project first. Okay. In this case, what we're doing is we're going to use a couple of different things to hook into our continuous integration system. Specifically, we're going to use ESLint, which is an ES6-based style checker, Istanbul to do code coverage analysis, and tape to actually run some unit tests. Right? So if we go look at this project, see that we don't really have much in here. This is just a sample project, obviously. So when we go and look at our test, you can see we're just using tape here, and we have some basic assertions around the test equals something, and then we end the test, etc. Right? But if we go look at our package.json, the way that we run this is we say run Istanbul with coverage mode and use tape as the test runner, and these are our test cases here. Right? So if we drop to the command line, what we're going to do is use what's called npm scripts. So you can see that this is in the script section of our package.json, and we have a few different things here in terms of our npm scripts. But if we go run npm run test from the command line, this should go run our unit tests. Right? So you see npm run test. It says I'm going to go run the test in the system, and we're going to basically see if everything passes or not. And you can see obviously it passes. That's no fun. So if we go into our test case here and we go break this, so let's set this to be 30 or something, I don't know. Right? Let's see if we can break this. And of course, it's going to be fine for now. And again, the specific approach we're using here is instead of using a gulp file or grunt file, we're just running this as scripts and running these tools directly as what we call npm scripts. So we can see we have a linter, we have some tests, etc. And we can run all this from the command line while we're doing development. So let's run another one of these. Let's run the linter. Okay. Right, so now the test should fail. So you can see that we have 50% branch coverage, and again, this is specifically Istanbul running over our project. So it says Istanbul cover tape. These are the tests that we want to run, and you can see that it gives us some metrics in terms of how much stuff we've actually run and what our overall code coverage is. So we can come in here and also run another npm script. So we'll say npm run lint, and in this case, you'll see that we have a bunch of problems. That to-add is defined but never used. We have a missing semicolon, et cetera, et cetera. So the way that this runs again is when we run npm run lint, for example, it just goes and runs this specific tool, in this case ESLint, and what we're saying is just run to get index.js. And of course, we could use a wildcard like this to go and give us an idea of all the different things that we want to run our test against, or linters, or whatever it may be. Okay, so this is how we run the basics from the command line. Now, next step is that we're going to integrate these into Jenkins, which is our build tool. So you can see we have a couple of extra tasks that we'll talk about in just a minute. All right, so let's get into our slides a bit and talk about a couple of different CI tools. So there are a few CI tools that we can use to give us the ability to run in an automated fashion, our unit tests, code coverage, other things like that. So we have Travis and Jenkins. So let's talk about Travis very quickly. Travis is essentially a cloud-based tool that does continuous integration for all sorts of different projects. It is based in the cloud, but we can run Travis on our own servers if we want, but that is not free, unfortunately. You have to pay for that. So what we do to create a Travis project is we create a .travis.yml configuration file, and then we configure Travis in the cloud. So if we drop down into our project real quick. All right, so we can see in this specific project we have a travis.yml file here. And all we do, we say, is this is a Node.js based project, and this is the specific version of Node that we wish to use to run this project, right? So once we have all that set up, we can go to Travis in the cloud and set up our project. I'll have some screenshots I'll show in just a second. And essentially it uses a GitHub trigger so that when you check something into Git, it automatically notifies Travis and says, go and build my project, right? So if we look at a screenshot real quick, You can see for this specific project, whenever if we were to make a change and check it into Git, or specifically GitHub, in our private repository or public repository, it would go and build the project just like we were going to run it from the command line. All right? So I don't want to talk about Travis too much because it is a cloud-based tool and most people are normally interested in running their CI system within their own cloud or within their own servers. And that's where Jenkins comes in. You probably already use Jenkins to run your Java projects or other projects, whether Java or JavaScript. Jenkins can run anything. It's just a general continuous integration and build server. And again, it runs on your own hardware. It's open source and free. Right? So our 3 goals for our continuous integration within our JavaScript project is to do some linting, code style checking, again, code coverage, and also do some automated unit tests. So the 3 tools that we'll use to do this are ESLint and JSHint. We use Istanbul for code coverage, and we'll use tape. We could use Mocha, or we could use Jasmine to actually run unit tests. Right? So the way that we set up Jenkins is we essentially fire up a WAR file. So if we go drop to the command line, so I already have Jenkins running here, so let's kill this real quick. Make the font a little bit bigger. Right? And you can see that there's a WAR file right here. So we just do java-jar jenkins.war. And this will fire up the Jenkins server on this specific machine. Take a second for it to come online. All right, so Jenkins is fully up and running now. And let's just make this a little bit bigger. Not that big. Okay. And we already have the demo project set up in here. So let's have a look at how we would do this. So to create a web/JavaScript project, we would go into new item, create a freestyle project, and configure some of the settings for it. Right? I'm not going to go through all of them right now. I'm just going to show the example project that we already have set up. Okay. So go into configuration, and here's our Jenkins sample. And in this case, what we're going to say is let's just use Git, and rather than using a Git server in this case, I've just set it up to point to a Git project that is on the command line, which is what we were looking at just a second ago. So if I go into here, our Jenkins example project, and you can see that right here we have our Git, or .git, so this defines our Git project. And once we have that declared, we can set the specific branch we wish to use, which is master in this case. And we do have to send the poll SCM to true to be able to have Jenkins run even with a GitHub trigger. So what we could do, if we wanted this just to run automatically, is we could use a cron tab style entry to say run this project every 10 minutes or do a build every 10 minutes. But what we prefer to do is have some kind of SCM hook to come in and actually tell Jenkins to go run, which we'll look at in a few minutes. Okay, so we have that set up. We can also now tell Jenkins what specifically we want to run. So we'll say for this project, run npm install, run npm CI test, and run npm run CI lint. So if we go back to our source code and look at this, we'll see that these are the 2 targets that we're specifically having it run, right? So these are just npm scripts as we talked about before. And the key difference is that when we just ran this from the command line previously, whether it was the test or the lint, right? So if we go run this, you'll see from the command line we can just go npm run test, and this just runs that specific target against our project. The additional thing that we have to do is we have to have our npm script output some results for Jenkins to pull into its system. So we still run Istanbul cover tape like so, right? So tape is our test runner. Istanbul is what we use for the code coverage. These are the things we're going to test. And in this case, what we're going to say is output the results to test.tap so Jenkins can import them and show them in its console. And Istanbul report Clover. So what this second step does is that it says, take the results that were produced and output them in a Clover-style output file. Similarly, for CI-lint, this is what our Jenkins server will use to be able to run our tests for us and our linter for us and import them. So if we go look at this, you'll see we say ESLint, right? So previously we just did ESLint with the stuff we wanted to have it run the linter against. In this case, what we'll say is ESLint-F. In the format that we want to output it in is called checkstyle. These are the files that we're going to run it against, and this is the output should go into this specific file. Right? So if we drop to the command line and we go run ci-lint and ci-test, you'll see that we had a failure, but that's fine. Right? We'll go into the failure in just a minute. But now, within this directory, you'll see here's my checkstyle result.xml that we've got. And if we run ci-test, we should get a test.tap and some Clover test files. So let's go to our command line and run this. Okay, so it's going to go run some stuff, and you can say that it's writing the coverage output files and the reports in these specific locations. So if we go into the coverage directory, we can see that here's our clover.xml. And again, the reason why we need to output this stuff is so that our CI server, Jenkins in this case, can import it and show it to us in the console. And so if we go back to our test here, or to our project, you can see that here's the tap results, here's the code coverage, and we can drill into these to get a better idea of the things that we had which passed or didn't pass or whatever. Right? So if we go back, we can look at our code coverage, and we can see that just like we ran from the command line, we have 50% branch coverage and all the other things are covered, et cetera, et cetera. Okay, so how do we set those two things up to work with our Jenkins server? And so we have Git configured. This is the things that we want to run. And what we do is we want to add what are called post-build actions. So you can see that these are already grayed out for tap, checkstyle, Clover. Right? So we've added those post-build actions for this project already. So what we say is, for the test results, we say, go find the test.tap file, and we can have some advanced options here if we want in terms of how we wish for this to appear in our console. And then we also added the checkstyle importer. And you can see if we look here carefully, what this tells us is that it will automatically look for checkstyle result.xml unless we want to specify a different file name, right? So we don't need to necessarily put this in here, but we could. It would be redundant in this case to do that. And finally, for our test coverage, we say Clover report directory is called coverage, Clover report file name is clover.xml. And again, we got those when we ran npm run ci-test and ci-lint. And again, if we go look at the coverage directory, you can see there's Clover, coverage, etc. in this file. So we have all this defined, and one of the things that we can do with these metrics is we can say there's specific target metrics that we wish to hit for the coverage. We want to have at least 70% method coverage, 80% conditional coverage, 80% statement coverage, etc. Right? So we have these specific things that we can say will pass or fail the build depending on how we wish to assign these values. Right, so we have pretty much everything covered here in terms of our three different tools. So let's go back and let's actually run this. Right, we'll talk about how we actually trigger this from SCM in just a minute. Right, but you can see that right now is going to go and try to build that. Should just take a second. Now we have build number 22. And we can drill into this and look at our test results and look at our extended results if we wanted to. And of course, we have our checkstyle warnings here. So if we hover over these, you'll see, just like we saw from the command line, looks like we're missing some semicolons, and we're expecting a parentheses or some other syntax-related issues. Strings must use double quotes, etc. Right? So these are some of the basic linter failures that we have in our project that can show up here. All right. So let's look at a couple more things around the configuration and discuss some of the best practices around building and setting up continuous integration for your project. Right, so if we go back to what we're doing to run this, right? So you can see one of the first things we did is we did an npm install. So this takes a long time to do typically, right? Especially if you're using a framework like Angular or React or whatever, doing an npm install can take quite a bit of time to go and grab all the dependencies from our repository and install them. But the reason why we do this is we don't check in to our source control system, the node modules folder, right? It's commonly, the common practice is to not check it in because the node modules folder typically contains things which are operating system specific. So what we prefer to do is run an npm install in our project to go and grab the dependencies we need and put into here. And the reason why we do an npm install when we run this in our CI project is to specifically go and make sure we have the correct dependencies and we have what's called a reproducible build. Because if we don't do this and we just had a npm install not done with a populated node modules folder, it could lead to cases where you get basically builds which are bad because there's some kind of dependency that is wrapped up into our project. So for example, if we go look at a React project real quick, you'll see that, for example, in this React starter kit, we go find a populated node modules folder. So these can be pretty big sometimes. So right, so here's, for a sample project, here's our node modules folder. If we go into here, you can see that there are dependencies that we want to get reloaded every time we do a build. We basically want to make sure that we pull the latest versions of the libraries down that are specified within our package.json rather than having them just stored locally. So it's kind of a way of just doing a clean before you go and do a build. You ensure that you have the latest versions of the libraries or the correct versions of the libraries, and there's not any extraneous files which are making it into your build, right? So you get reproducibility around them. All right, so we've looked at the configuration quickly. Let's also go have a look at what we do in terms of setting up a build trigger around this. Like I said, we could just use a cron tab style entry here to go have this build run every 10 minutes like so if we wanted. But what we prefer to do is we prefer to have a hook so that when our Git repository is updated, or somebody does a check-in essentially, that we go and tell our Jenkins server to run the build. So let's go into Jenkins example and let's go into our .git folder in here. And you'll see that this is a standard .git folder. It's going to have our configuration in it, like so. You can see that we have a couple of different configurations in this, but what we're specifically interested in is this hooks folder. So what we do in here is we specifically want to put in what's called a post update in our Git. So if we were to open this up, right, you can see that this isn't really actually doing anything right now. But what we would do to let our Jenkins server know that this Git repository has been updated or somebody's made a commit to it is we would use a simple command like so. We'd say send a HTTP notice, i.e. make a HTTP call. And what's the name of this specific configuration? This is Jenkins sample. Okay. So we would take this and we would say go and hit the Jenkins sample and go and specifically trigger the build. Okay? So essentially what we do again is we go into the Git hooks, specifically the post update hook, and we say make an HTTP call back to our Jenkins server and say go and do a build. Right? So this is literally as simple as this in terms of putting this together. So let's quit this. We don't want to put this in. Again, the place we're at is in our git.git/hooks. Specifically, we want to look at post update. All right, so let's get back to our slides and make sure we've covered everything. And so we set up the project, did new freestyle project. We talked about Git and using, in this case, just a local repo URL. Of course, we would want to point this at our Git server. We talked about poll SCM. Okay, we went and set everything up. Now, one thing that we can also do around this is we can automatically have Node provided by setting some kind of installation path, right? So if your server doesn't already have Node installed, we can say go and grab the Node binary from this location and install it into that specific server if it doesn't already exist. That's useful if we want to do kind of master-slave type configurations, i.e. have a bunch of different servers running our build instead of a single server running our build if we have a number of different projects or if we do builds a lot, if we have a lot of developers on our team, right? So one common thing to do is to provide the NPM and Node and say, go use this specific installation or this binary and install it if it doesn't exist, right? And after we've done that, or after the server's done that, the Jenkins server will go and run our tests by just executing something from the command line. Right, so in terms of executing stuff from the command line, if we come back to our project, how is it that Jenkins knows that this project has passed or failed, right? So if we go look at, for example, at the last time we ran this, you can see that this project has is in the success state. But how does it know that, right? Even though we have kind of some check style errors and or some test failures and other things like that. So the way that it knows this is when we did npm run ci-lint, for example, we actually got something that looked like an error, right? So you can see it ran this, we got an error. If we run this without the CI tag, so we can see like the full output, you'll see that we don't actually get an error when we run this, or we do get an error when we run this, but these are just linter failures, so they're not necessarily things that should necessarily stop our build from running properly. Right? So you can see we're just missing some semicolons, and we have some style-based issues around this. But you can see that when we actually ran this from the command line, we actually got an error. And when you run something from the Unix command line and you get an error, what happens? We get an exit code other than 0. If something runs successfully from the command line, right, so if we were to run ci-test, for example, you'll see that there's not an error because our test cases are passing. So what happens is when we run this specific command, we get an exit code of 0, which means everything was okay. When we run it like this and we get what looks like an error, the exit code will not be 0. You can see the exit status is 1. So when Jenkins is running our project, it looks for that exit code of 0 or something other than 0 to determine if the build has failed or not. And that's how it determines if everything has worked properly or if it should set the build to be broken or functional or whatever, right? So you can see that when I ran this in the past, we had some broken builds around a test failure. So in this case, you can see that this specific build had a test failure break around this specific should be equal test. Right? So this is how Jenkins knows whether or not things have failed. It looks for the exit code from the actual command that you tell it to run. All right, so let's check, make sure we've covered everything. All right, so we look at for the exit code to make sure if it's 0 or 1. That lets Jenkins know if this succeeded or not. We talked about adding a build step, how to publish the check style results, tap results, and how Jenkins imports them into its system. Okay, and we integrated all this stuff in just using simple npm scripts. We could have used a gulp file or a grunt file, i.e. a build tool like grunt or gulp, to wrap all these different things in. All right, this is just a Node project, obviously. So we run all this stuff, so we'll skip over it. So in terms of some next steps, some of the other things that we can do by configuring Jenkins is to email all the people who committed since the last time the build was done if we get some kind of failure. So if the build fails, we can say, oh, I did a check-in and 2 other people on my team did a check-in since the last time a build was done. Let's email them and let them know that the build failed. Right. The other thing that we can do is we can have isolated build environments. We can set up multiple Jenkins servers so that we can have things running and not getting queued up to run because sometimes it can take a long time to go and run unit test and run the code coverage and things like that. We can also do things like push button production deployments or deployments to our test environment directly from Jenkins. So the way we can do something like that is if we go into our configure, we can again go add some post-build actions, and we can say build another project, archive the artifacts, et cetera, et cetera. And what this will allow us to do is again just have some kind of hook in for doing extended or extra functionality. Right? So the other things that we haven't really talked about is how do we secure this, right? Because right now my Jenkins server is unsecured. Anyone can go to this URL that is running on my system, and they don't need to log in. They can go and change the configuration and run a build, etc. So what we can do is we can go into our Jenkins configuration, and we can say go and add some credentials. Right, so you can see that we just have it in unrestricted mode right now. But we can go and add some credentials so that people actually have to log in. But this is typically not needed when we're running this inside of our own firewall or on our own servers that are not exposed to the internet. Okay, so in terms of how do we set this up for a common type of framework like Angular or React or something like that, right? How do we set up a project? And right, I've shown some basic build scripts, and this repository is on my GitHub account, so you can go and look and borrow some of the specific code that's there for building your own system. But one of the things that we do is we use a starter kit that already has a lot of this stuff built into it, right? So we don't actually go and write a complete gulp file or grunt file or write these npm scripts and set everything up. What we typically do is we'll just go find a good React starter kit or a good Angular or Angular 2 starter kit that will have all this stuff set up, and that way we don't have to spend a lot of time actually putting this stuff together ourselves. We can just borrow stuff that folks have done, right? So a little while ago I showed a starter kit that was based on React. Right, so if we go look, for example, at this React starter kit, and if we go have a quick look at the package.json that's in here, you'll see that this is using a bunch of different dependencies. Specifically, this is using Gulp to do automation, but it uses Jest, which is a tool for doing unit tests for React-based projects. But then if we go look at the Gulp file, we'll find different things that have already been set up for us. For example, the Webpack configuration to do bundling, running unit tests, and code coverage and other things like that have already been integrated into this very large, in fact, Gulp build file. So the point here is that you don't necessarily have to build all this stuff yourself. You can just go borrow these things from a starter kit rather than having to hand craft everything. Someone's already gone to the trouble of putting everything together for you. So, like I said, we like to borrow stuff from other people, especially these kind of nitty-gritty things that can take a long time to set up and understand. So we just borrowed from a starter kit, and we kind of make sure that we don't diverge too far from the starter kit. So that's what the first bullet here is. We're following the herd, i.e. what are some common practices that other people do, and not diverging too much from that. As time moves forward and people upgrade the version of React or the test library or whatever, we can simply fold those changes back into our own system rather than having to go and do those updates ourselves. Right? So it's nice that a lot of this stuff is open source. We can just borrow stuff rather than having to go and figuring out everything on our own. All right. So there's some links here. The slide decks will be available on the Devoxx Poland website in a few days, I think. But that's the end of this specific discussion. Is there any specific or general questions around what we talked about? So should we get the lights up? Okay. So any specific or general questions around what we discussed? So we walked through Jenkins setup, how we use npm scripts to put this together. We could have used a grunt or a gulp file to also put together a build system. And we kind of saw how it integrated, how Jenkins pulled in all the output. So we kind of went all the way around and showed a complete example. So, any questions or comments? Yes, sir. Yeah. 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 Okay. Yeah. So the question is when I was showing the configuration for our project. All right, let's go back to our project real quick. One of the things I said that we do as a best practice is we do an npm install and then we go run everything. So we're essentially doing a clean, if you will. And the comment was, in the sample project we didn't have many dependencies, but in a real project, like for example, if we go look at this project, if we go look at the package.json, you'll see there are a ton of dependencies in here, right? And these dependencies will have sub-dependencies, and instead of taking a few seconds to do an npm install, it could potentially take minutes or tens of minutes, which is completely true. If I were to run an npm install for this project, it would probably take somewhere between 4 and 5 minutes, depending on how fast my internet connection is. And that's a long time, obviously. So how do we alleviate that long time for doing an npm install, is the question. So there are a couple of different options in terms of this. What we can do is we can use a server that goes and caches the central npm repository. Okay, so that's one option. So inside of our project descriptor, we can say this is where we want to point npm to go and get the dependencies rather than getting them from npm globally. The other thing that we can do is when we install something, right, let's say we were going to install Lodash or underscore or whatever into this project, we can specify the cache limit on this. So when we do the --cache flag, what this says is go and install Lodash into this project, but also tuck it away locally on the file system under user. It'll be somewhere under user local. I'm trying to remember exactly where. But basically go and tuck it away into user local so that the next time I do an npm install of this same library into this project, instead of going and grabbing it from the repository, it'll go and just grab it from the local cache, which is under user local. Right? So this is another way that you can greatly speed up the npm install part of doing a build. Okay, so a couple of different things. You can just use the cache option, right, and give it a really large number so that it'll just be cached forever. The other option is you can go get a commercial npm server that will cache the main npm repository that's upstream. Okay? All right. Any more questions? Yes, sir. What are best practices for continuous delivery? Now, that's an excellent question. So what we do is we don't specifically do continuous delivery to production. We just do continuous delivery within our own kind of test environment and staging environments. Okay? But in terms of kind of best practices around CD, one of the things that we saw is always do an npm install. The other thing is to ensure that we always get properly versioned or things that actually work properly even after we run tests and other things like that is when we specify dependencies. For example, this is using React here. You can see what we do is we specify an exact version number because one of the things that we can do inside of a package.json is we can say, give me the latest minor version or the latest minor version by using a caret instead, right? So here's a caret up here, right? So we could say, give me the latest minor version or the latest minor version like this, right? But in terms of continuous delivery, doing something like this would be an anti-pattern. We want to lock in the core framework stuff that we have to be a very specific version so that we don't get any variability or changes in our build. Okay, so there are a couple of things like around that we've looked at in terms of having better CD. We don't do CD all the way to production, but even within our test environment, we lock down the version numbers. We do an npm install using some caching methodologies, and that's pretty much all that we do in terms of that. Okay, all right, we're at the end of time, so thank you for coming, and I hope you enjoyed the session.